Hi everybody, welcome back to chemistry. In this video, we're going to go over section 1.4, which is all about key math skills that you're going to need in chemistry. So we'll review some things like place values, positive, negative numbers, percentage, solving equations, and interpreting graphs. So remember that a graph represents the relationship between two variables. So looking at this graph right here, we've got our x-axis, which is your horizontal axis, and that is measuring temperature in degrees Celsius. Units are always really important in chemistry, and we'll work with them a lot, but starting to recognize what units things are being measured in is really a good idea. And then our y-axis over here is our vertical axis, and it's measuring volume in liters. So we use graphs in chemistry to represent data that we have. So in this experiment, it looks like they were testing the volume of a balloon versus temperature. So how does the volume of a balloon change as we increase the temperature going towards the right? So you can see we start at 0 degrees Celsius and we end up at 100-ish degrees Celsius. And then likewise, we start at 22 liters of volume, and we end up at, or about 22, and we end up at around 30. So if you'll notice, the balloon is getting larger, the volume is getting larger as we increase our temperature. So just starting to think about how we can interpret graphs and how they can be used as a tool in chemistry to relay information about our experiments. And we'll talk more about that in a little bit. So identifying place values, I'm not going to go over this too much, but here's some review for you if you need it. So remember that there is the thousandths place, the hundreds place, the tens place, and the ones place. Those are all before the decimal point, right? So there's an imaginary decimal point right here, right? And all of the DS, SS, that is all indicating that we're talking about place values before that decimal point, okay? And then over here, you see our decimal point is right there. So this is our what? Yeah, it's our ones place. So we can see that over here. It's just like our 8. It's in the same spot right before the decimal point. And then the rest of the place values are talking about decimal places that are after the decimal point. Or sorry, place values that are after the decimal point. So, and you know that because they have a different ending. So tenths, hundredths, thousandths, it's hard to say. And it's kind of hard to hear the difference probably on video, but just look at that ending is a DS or a THS. And that might give you some hints as to which value. So I'll let you go over that a little bit on your own. And let's move on. I'm not going to go through the learning check. You know what? If you want to, you can pause the video and try it out. Okay. Which decimal place is that one? Yeah, it's the hundredth place after the decimal. All right. So using positive and negative numbers in calculations, I have a few tricks up my sleeve for some of these, so I'll teach you those in the way that I was taught them, and then if that doesn't work for you and you know some other way, like totally use the one that works for your brain, right? We all have different ways of thinking, So in this first bullet point, it says a positive number is any number greater than 0 and has a positive sign. We often don't even show the positive sign, so that just means that when we write, 3, we don't usually put a +3 there. It's just assumed that it's positive. If we see a negative in front of it, that means it's a -3. And if it helps, I like to think about a number line. Whoops. So why is that happening? Oh, I'm on eraser. So if you have 0 here, Your positive numbers are on the right side of the number line. So let's go 1, 2, and 3. That's our positive. And then your negative 3, 1, 2, and 3 is right here. So if you're going on to the right, we're getting positive, and going to the left, we're getting negative. Sorry, negative. My writing's not so great today. I apologize. So hopefully that helps, kind of seeing it represented that way. If not, you know, take it or leave it as it helps. Okay, multiplication and division of positive and negative numbers. So I always kind of remembered it in the way that if you have two positives, that makes a positive, two negatives makes a positive. But if you have two different signs, a positive and a negative, you get a negative. So same sign, this is a positive number and a positive, you get a positive. Same sign here, same, they're both negative and you get a positive, right? Another trick that I learned for fractions is if you can draw a vertical line through both of the numerator and the denominator, then it's positive. If you have -6/3 and you try to draw a vertical line and it only goes through one, it's negative. The answer is negative. So I don't know if that helps, but that's what we learned in grade school for me. And then for this next bullet point, number 2, notice we have one negative sign there. So we get a negative sign out from it. If this was -2, we'd actually have a positive here. But because it's not, and we only have one negative, our answer is negative. So hopefully that's a little bit of review for you on that. Now, addition of positive and negative numbers, I think, is a little bit trickier than multiplying and dividing. So when you have two positive numbers being added, the sign of the answer is positive. That's probably something that you remember, right? We kind of do it intuitively. So 4 + 3 = 7. We know that we're not going to just randomly get -7, right? And if you look up at your number line, again, that we drew up here, you can kind of see that, right? If I start at 1 and I add another positive 1, I get to +2. Now, if you have two negative numbers that are being added, the sign of the answer is negative. So just like when we have two positive numbers that are being added, we're getting more and more positive. If we start off negative and add more negative, we get even more negative. So again, looking at the number line, if you start off at negative, oh gosh, sorry you guys. If you start off at -1 and we add -1, so -1 plus -1, you're getting more negative. So we're going from here to here, and we're ending up at -2. All right, so I hope that makes sense. If not, please feel free to ask me any questions you have. I'm also, I have lots of other resources, so if you need any more review on math, I can send you some from other things that I've found in, my time as a professor. Okay, so when a positive number and a negative number are added, the smaller number is subtracted from the larger number. And the result is the same sign as the larger number. So this is a little bit weird, the way that they say that. But what you're kind of doing is, if you start with, I always look at my bigger number. And I say, okay, I'm subtracting my smaller number from my bigger number. And that kind of feels a little bit intuitive, right? So 15 minus 12 is 3. And then I decide what sign am I going to have in front of it. And the way that I figure that out, so right now I know, okay, my number is going to be 3. 15 minus 12 is 3. And then, am I going to have a positive or a negative sign? Well, to know that, you have to look at your bigger number and say, is my bigger number positive or negative? If it's negative, my answer is going to be negative. If my bigger number is positive, that would be positive. So say this was positive and this was negative, then this answer would be positive. Okay, so you take the sign of your bigger number, and that's what determines the sign of your answer. But either way, you're subtracting, okay? Because notice we didn't just add 15 and 12, right? We immediately subtracted. Okay, so when two numbers are subtracted, change the sign of the number to be subtracted and then follow the rules for addition. So I would amend this by saying two numbers, or let's go here, two numbers in a row are subtracted. So here we've got minus our positive sign. So we just do 12, the bigger number, right? Just like we did up here, minus the smaller number, and we get positive 7. Why is it positive? Well, our bigger number is positive. Now, this part is the tricky part, right? So I don't know if the way that you learned it in grade school, but the way I learned it was two negatives make a positive. And what you could do, the way that I always kind of remembered doing it, was putting a little plus or a vertical line through those. So if they're right next to each other, you can make those a positive. And then you're following the same rules as in this section here. So subtracting and changing the sign of the number that's going to be subtracted. All right. Calculator operations. You can pause here if you need this. I think as you are kind of working with your calculator, it'll all just start coming back. So I wouldn't worry too much about this, but if it helps, you can do that. You can look at that. Calculator operations, they have an example of how you do that. Like I said, entering things into your calculator is something that we'll be doing all the time. So we'll kind of learn as we go. And if you have any questions, always let me know. Calculating percentages, we're going to do a lot of this in lab especially because we use percentages to figure out how, it's called percent yield, how much of our substance we yield or get back at the end of the reaction. And that's kind of jumping into the weeds a little bit, so we'll talk more about that later, but I just wanted to let you know how we actually apply this. So anytime you're using fractions, remember that you have a part. Sorry, that's kind of hard to see. Let me move that over a little bit. A part and a whole. So I have 8 chemistry books out of a total of 32 books. So part over my whole, right? And that's a fraction. To get that fraction into a percentage, you multiply by 100%. I mean, you can just call it 100. You're just basically multiplying by 100. You don't have to put a percent sign in there. And that's going to equal 25 chemistry books. So scooch this over for a second and let me show you something. So here I'm looking at just these two numbers here. So I have a fraction, 8 over 32. When I plug just that part into my calculator, the number I get is 0.25. It's a decimal, right? Because anytime you have a fraction, you can convert it into a decimal and vice versa. So, and I can show you how to do that on your calculator if you need help. So I basically, when you plug this into a calculator, you're dividing 8 into 32 and you're getting 0.25. To get that into a percentage, you're actually just moving the decimal place over. So now I'm going to do my next step, which is times 100%. And I'm going to get out to 5%, just like I see over here, 25% chemistry books. So the number of books, or the percentage of books that are chemistry books, is 25%. And if you want a quicker way of doing this, if you're like, oh, I kind of get this concept, you can move this decimal right here over to the right twice. And that's basically what you're doing when you're multiplying. So these are the same thing. And you'll see that you get the same number, right? I've now moved the decimal place here, so I have 25, and then you're going to say it's a percent. And you're not going to leave that decimal in there, right? We don't represent that unless we really need to. Okay, keep moving along. So solving equations. So another important part of chemistry is being able to solve kind of like basic algebraic equations. So remember, when we're solving algebraic equations, we're usually always trying to solve for an unknown variable. Sometimes you'll have more than one unknown. In like 162, you'll start working with that, but I promise it gets easier as you do it. So in this case, we're solving for x, right? So how are we going to get x alone? Pause the video and answer that question. How do I get x alone? Yeah, so I'm going to subtract 8 from both sides. So let's do this over here. So I'm looking at this and I'm like, I want that x to be alone. So what's in the way of that x being alone? Well, 8's here, and like, let's move that guy over because he's not being helpful. The only way I know how to get rid of this 8 is because I have a positive 8, I've got to subtract 8. And that way those actually cancel out, right? A positive 8 minus 8 is 0. But whatever I do to the left side, I have to do to the right side. So I'm going to subtract 8 from the other side too. So now I have 2x equals 14 minus 8 is what? Yeah, 6. So now, is my x alone? Have I succeeded in getting x alone? No. I need to get rid of this 2 here. So how am I going to get rid of that 2? What's the operation here that you don't see? Is multiplication, right? So I got to multiply both sides by 2. Because what I do to this side, I have to do to this side, right? So once I do that, this cancels out, and I get x equals 3. Let's just double check my work there. X equals 3. And the way that you can also double check if you were ever unsure is you should be able to, if you did this right, plug in your answer in here and get the correct answer. So let's do that. So we have 2 times 3 plus 8 equals 14. So 6 plus 8, does 6 plus 8 equal 14? Yeah, it does. So we did this correctly. Okay, I hope that makes sense. If you need any more, a quick review of how to solve equations, I'm always happy to do that. I actually really like math, so. And I didn't always, so I remember what it's like to be confused about math. Okay, so learning check. Go ahead and try to solve this equation. And you have lots of variables, but you're going to look for P1. So go ahead and solve this equation for P1. So you're trying to get P1 alone. So pause the video, try it out yourself. All right, and before I show you the answer, let's just do this on our own. So if I'm trying to solve for P1, I need to get this V1 that's in my way away from me. So away from my P1, I should say. So how am I going to do that? Well, the way that I think about it is right now there's an invisible multiplication sign between that P1 and that V1. Right? I don't see any addition. I don't see any subtraction. I'm not dividing anything. So there must be a multiplication sign there. So, and there is. So what's the opposite of multiplying? Yeah, dividing. So let's divide by V1 on both sides, because whatever I do to the left, I gotta do to the right. That's just how it works. It's the law. Okay, so now I can cross off my V1 and my V1, and I'm left with P1 equals P2 over V2, or sorry, P2 times V2 over V1. And I don't know if you're anything like me, but if you are, when I first look at this, it can feel a little bit intimidating because there's all kinds of variables and I don't have any numbers that I actually know. That's okay. It's all right to just solve the equation without any actual numbers. when we get into gas law, because this is actually it's called a gas law, one of the gas laws. When we get into this, you can always plug in the values that you have. So say you got measurements and you had P2, you had V2, and you had V1. You could plug in those numbers. You could plug in these numbers first into here and then solve for your P1, right? So P1 will be your variable. I'm jumping ahead, sorry, but yeah, we'll talk about that later. Or you could always solve it like we did here, where you get P1 alone and then plug in all your values that you have on that side. Some people prefer one way and some people prefer the other way. All right, and let's check our answer. P2 V2 over V1. Yep, we got it right. Cool. Okay, interpreting graphs. So again, graphs represent the relationship between two variables. There's always two perpendicular axes. So there's a horizontal axis, which is your x, so that's going like left and right. And then there's your vertical axis, which is your y, which is going up and down. I'm going to skip that previous slide. So when you're interpreting graphs, the first thing I do is I read the title. Here's the title of my graph. And notice that this title is descriptive. Volume of a balloon versus temperature. It's telling me the relationship that this graph is actually representing. So it's representing the relationship between volume and temperature for this balloon. So as I change the temperature, what happens to the volume? So this x-axis is actually what's called our independent variable. And you'll hear this term if you take biology as well, physics. Lots of sciences use graphs to show their data. So the vertical axis is always showing your independent variable, and your independent variable is the thing that you are not changing in your experiment. So, or the thing that is not dependent on your other variable. I said that really confusing. So let me break it down. So if you have, we're increasing our temperature in degrees Celsius, right? So looking here, we're going from 20 to about 50. Right? We've increased our temperature. And what we want to know is, hey, as I increase my temperature, what happens? How does my dependent variable, how does this other variable change when I increase the temperature? So in other words, the value on your y-axis is dependent let me make that more clear. Independent variable is x. The value on your y-axis is dependent on what your x value is. So when I'm at 20, my y value is some number. When I'm at 60, my y value is some number. When I'm at 100, my y value is some number. You're changing your independent variable, and your other variable is changing as a result of that. So, I thought we had one more slide here. I guess not. Okay, so let's just read this side thing here. The line on the graph indicates a direct relationship that the volume of a gas in a balloon increases with increasing temperature. And that can be used to determine the gas volume at various temperatures. So I hope that makes sense. If you have any questions, again, please let me know, and I'll see you later. Bye.